We have different kinds of equations that can represent reactions in aqueous solution. What we've been writing is what's called a molecular equation. So here we have neutral formulas for each compound, and we indicate the state symbols and we balance it and we get something like this. And that's what you might think of as a regular chemical equation. But that does not tell us what's actually happening in the solution. Because what's actually happening in the solution is potassium hydroxide, those ions separate from each other, right? So a complete ionic equation is going to show all of the ions as they are present in solution. Now, something like a solid here, are those ions separated? No, they're not. So complete ionic equation shows all of the ions. A net ionic equation only shows the things that are getting involved. The other people that just came to the party and didn't get hooked up with anybody, those are not shown in the net ionic equation. So solids, liquids, and gases are always going to be just copied down. They're never splitting up. If it's aqueous, most of the time you write it as ions. The exception is a weak acid. So weak acids, solids, liquids, and gases, those are all written as neutral chemical formulas. Everybody else is going to be written as separate ions. So here's an example, the lead nitrate and the potassium chloride. So we look at the state symbols from our molecular equation. We look at this one, it's aqueous. Is it an acid? No, it's not, so we're going to separate it into its ions. If we look carefully at that formula, we should recognize there's a lead ion, lead 2, and there are 2 nitrate ions. So we're going to get a lead 2 ion and 2 nitrate ions. Then we see this one, KCl. Is that an acid? No. So it's going to be written as separate ions. There are 2 of those units, so I'm going to have 2 potassiums and 2 chlorides. Over here, this one's a solid. That means it's not separated, right? The lead and the chloride are very much together. And so we're going to write it that way because that's how they actually are in the solution. And then potassium nitrate, aqueous. Again, check and make sure it's not an acid. It isn't. So we've got 2 potassiums and 2 nitrate ions. Any questions? Yeah.
How do you tell the difference between strong and weak acids?
That's an excellent question that we'll get to in just a minute. The difference between strong acids and weak acids. So here we have the complete ionic equation, shows all the ions that are in the beaker, right? Some of them, though, are just spectators. They're just watching. It's like you go to a boxing match, you're a spectator, you sit in the stands, and you watch the 2 guys beat each other up. Not sure why people like doing that, but, different strokes. Do you come home with a black eye and a bloody nose? No, you were just watching, right? Nothing happened to you. So here, the spectators, nitrate started out by herself. Nitrate ends up by herself. Did anything happen to her? Did her Facebook status change? No. She's still single, looking for a cation. What about potassium? Potassium is exactly the same over here. We call those spectator ions. They're just watching. They're watching lead and chloride fall in love. So what we do is we cross out the spectators when we want to make the net ionic equation. And then we write down what's left. So lead 2 ion, 2 chloride ions makes lead chloride. So if you think about this, if lead had come with acetate instead of nitrate, would he still have fallen for chloride? Yeah, because nitrate didn't play any part in this. She was along for the ride, right? She just wanted to go to the party. Any questions? Consider this reaction occurring in aqueous solution, right? The complete ionic and net ionic equations for this reaction. So this is the molecular equation right here. We could call that ME, molecular equation. So the complete ionic equation, see, and this is where we need the acid thing, but they don't talk about that until a couple more slides. So anything that's aqueous will most likely be written as ions. Here, the water is a liquid. If it's a liquid, solid, or gas, you just write it as it's shown. You don't separate it or do anything to it. So this one starts with H. It's aqueous. It is an acid. And so then we need to know, is it a strong acid or a weak acid? And I'm just going to tell you it's a strong acid. Strong acids form strong electrolytes. They form lots of ions. They're going to separate into the ions. So I'm going to separate this one. If I have two of those units, then I have 2 hydrogen ions and 2 iodide ions. So this is going to be my complete ionic equation. And I'm going to have 2 hydrogen ions and 2 iodide ions. And then the next one, aqueous, not an acid, so definitely we're going to write that as separate ions. So that's barium 2+. And how many hydroxides? 2. 2 hydroxide ions. Because the formula tells me that. There's 2 OHs for every 1 Ba. And come over here. This state symbol is not aqueous. So I'm just going to write it down. Don't do anything to it. The last one is aqueous, not an acid, so separate that as well. If you're interpreting your chemical formulas correctly, you should end up with an equation that's already balanced. So it's a good idea to check. Any questions about the complete ionic equation? So the net ionic equation, we want to eliminate the spectators. Who are the spectators? Well, H2O is over here, but there's no H2O over here. So it has to be exactly the same. It came to the party and it left in exactly the same appearance, state, didn't get married or fall in love or anything, okay? Iodide, right? Iodide came and iodide left. So that's a spectator. So the net ionic equation, we only want to show who was involved in a chemical reaction. What's the other one? Barium. It's a little bit like doing a math equation like this, where you've got A on both sides, right? You subtract A from both sides and you get B equals C. It's kind of what we're doing here. Okay, so hydrogen ion and hydroxide ion are not present on this side. Water is not present on that side. We've eliminated all the spectators. There's almost always 2. And so we can write our net ionic equation. Net ionic equation. So we're just going to copy this down. So 2H plus plus 2 OH minus. Making 2 H2O liquid. Now what's a little weird about that balanced chemical equation? Do we need all those 2's? No. So let's get rid of the 2's because the most correct balanced chemical equation is going to have the lowest whole number coefficients. Okay, so here what we see occurring at this party is that a hydrogen ion and a hydroxide ion get together in relationship and make a water molecule. Any questions? I used to call this wife swapping, but that was just a little too weird. I like the party thing better.